In this lesson, we'll go over part, percent, whole, and some applications. We'll understand to identify part, percent, whole in given problems. Given 2 of the 3, we'll correctly calculate the third, and we'll apply part, percent, and whole to application problems. This lesson also relates to what we've talked about previously with fractions, decimals, and percents. So part, percent, whole, some examples of where our problems will be coming from. Things like, what is 52% of 598? 81 is what percent of 292? Or applying it when you buy an item, there's sales tax, and that's a certain percentage, 8.38 in Clark County, of the total price, so you're looking for a part. Okay, so in problems involving part, percent, whole, you're typically given 2 of the 3. So part, percent, or whole, you're given 2 of those, and you're being asked to find the third value. So there's 2 different ways to solve part, percent, and whole problems. Way number 1 is using this visual. It's set up in a triangle where there's a line going across horizontally, and then the bottom part is split into 2. The way this works is that you fill in the given values. So identify what you're given, put those into the correct spaces in the triangle. If 2 values are on the same level, so like percent and whole, you would multiply to find the missing value. Or if 2 values are on opposite levels, so part and whole or part and percent, you would divide to find the missing value. Something that's really important with this is that you have to work with percent as a decimal. So whether you're given percent and you're plugging it in, it needs to be a decimal. Or if you're finding percent, you would find it as a decimal and then make sure that it's in percent form. Second way is using proportions. So this looks like what's called is over of equals percent over 100. Is the part, of is the whole, and percent is just the straight percentage. It's not in decimal form. You would cross multiply and solve for the missing value. So when I go through our few examples, I will be showing both ways so that you can decide what will work best for you. And then when we go to our applications, I'll use the triangle visual. That's typically what my students gravitate towards, but if you have any questions about either method, I'm happy to help you. So example 1, what is 80% of 10? So solving the first way using the triangle, we're looking for what we're given, whether we're given the part, percent, or whole. Percent is the one with the percent sign. So we're given the percent here, and then this is equal to 0.8 as a decimal. When it says of 10, we have to determine if 10 is the part or the whole. Usually when we see the word of, that's denoting the whole. Okay, so we have our percent, and we have our whole, and we're looking for part. Since these 2 values are on the same level, we're going to multiply to find the missing value. So that would look like 0.8 times 10, which would give us just 8. So 80% of 10 is 8. If you get an 8 out of a 10 on a quiz, you would get 80%. The way this works with the proportion, I'm going to write is over of, percent over 100. So the percent, again, is 80. The of, what follows of, goes in the of portion of the proportion, and then we're trying to find the missing value. When you use this method, you cross multiply. So question mark times 100 is equal to 80 times 10, and then you would solve from here. So we have question mark times 100 is equal to 800. And then we haven't talked about solving equations yet, but to get this question mark by itself or to solve for it, we would divide both sides by 100 to get 8. Okay, so whatever way you do it, you would end up with the same answer. I'm going to use this example again, and I'm going to show you visually what's happening here. So remember that percent means per 100. The 10 is the whole, so what we can do is take the whole and divide it up into 100. 5, 6, 7, 8, 9, 10. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so pretend it's a little rough. I couldn't get a 100 by 100 grid on here. So pretend that these are equal squares. This whole represents 10. So if I divide 10 by 100, I would get 0.1, which means that each one of these squares would be 0.1, and so on. So pretend I'm going to fill all of those in. Okay, 0.1 everywhere through the squares. If you're taking 80%, you're taking 80 out of 100, meaning you would be taking all but 20 squares. So we're taking 80 squares, and each square is 0.1. So if you were to take 80 times 0.1, you would also get 8. So that's just a visual of what's going on here. You can solve it whatever way works best for you, but I like to bring in visuals whenever possible. Example number 2, 15 is what percent of 46? Round to the nearest tenth of a percent. So we have 15 is what percent of 46? What percent? We don't know the percentage, so that's what we'll be looking for. 15 is usually denotes the part, and then of 46, so 46 is our whole. For the triangle, when two numbers are on opposite levels, you divide. So 15 divided by 46. Now, I'm going to write this number down, and I'm going to go to a lot of decimal places so that we can talk about how to round. This would be 0.32608, etc. Remember that this is the decimal form of the percent, so we have to multiply by 100. So when we multiply by 100, we get 32.608, etc. percent. Now the answer says round to the nearest tenth of a percent, so this is where you round. You don't round at the step before 0.326, you wouldn't get the same answer. You round once it's in percent form. So the final answer here would be 32.6%. For is over of equals percent over 100, it says 15 is, so that goes in our is portion. Of is 46, and we're looking for the percent. So again, we'd cross multiply. 15 times 100 is equal to question mark times 46, and then we would solve from here. We would have 1500 equals 46 times question mark. Divide both sides by 46. And then with this method, you get the percent right away. You don't have to multiply. So the number you get here, you can round to the tenths place right away. Example 3, 72 is 15% of what number? So we have our percent. I'm just going to fill in both as we're going. 15 or 72 is, that's our part or our is. And then we're looking for of what number. So we're looking for the whole. With the triangle, if two numbers are on opposite levels, we divide. So 72 divided by 0.15. And this gives us 480. When we're cross multiplying, 72 times 100, which would be 7200, equals 15 times question mark or times x, and then you would divide both sides by 15 to get 480 as well. So solving part, percent, and whole applications. So with these problems, you'll have to grab the math out of the problem, you'll identify what is given and what is missing, and then put yourself back into the context of the problem to make sure your answer makes sense. Application number 1, calculating tip. So pre-COVID, whenever I'd go to a restaurant with friends, they would always hand me the bill to say, you're the math person, you calculate the tip. And it made me realize that not everyone is comfortable calculating tip, but it's a pretty practical skill to have. I know sometimes restaurants or receipts will do the math for you, but they're not always tipping on necessarily what you would tip on. So it's always good to double check. So you order from DoorDash. The total cost of your order is $52.37, and you decide to tip 18%. How much should the tip be? Round your answer to the nearest cent. Okay, so the total cost of your order, total cost is whole, and you're tipping 18%, so this is your percent. And then the tip, if you want to think of it in terms of part, percent, whole, the tip is the part that you're tipping on the whole. Okay, so if you set up the triangle, we have our percent as a decimal, we have our total, and we're missing the part, or we're missing the tip. If two numbers are on the same level, we multiply. So we would do 0.18 times 52.87. And when you do that in your calculator, we're rounding to the nearest cent, which is the nearest hundredths. So we would get, 52, I'm sorry, I've been writing the wrong number. 37. Okay, 52.37 times 0.18, which is 9.43. So you would be tipping $9.43. Application 2, Deandra has $600 in her savings account. She wants to save $2,250 for an upcoming trip. What percent of her goal has been reached? So this problem is asking for what percent. So that's the part we're missing. We have part of the whole being saved up. So if you look at this in terms of like a number line or a scale, this is $0. This would be 2,250, and 600, I'm just going to guess, is here. So when we're looking at what percent is 600 of 250, we're looking at this much out of the total. And again, you can set up the triangle or whatever other method you choose. We're missing the percent. We have the part, and the whole is 2,250. So in this case, we will divide because our numbers are on opposite levels. And whatever percent you get, I'm getting 0.266666 continued. So you multiply by 100 and then you round. So this would be 26.7%. And so with applications, you put yourself back into the context of the problem. Does your answer make sense? Well, visually it seems to make sense. She's not even halfway there. So it would make sense that our answer is under 50%. Application number 3. You had anticipated a large demand for a popular toy and increased your inventory of 1,500 by 30%, and you were able to sell 80% of your inventory. How many toys remain? So we're dealing with a couple of things here. We have a 30% increase, so let's say we're getting ready for, Prime Day, Black Friday, shopping holiday. So you're going to increase your inventory by 30%, and then you're going to sell part of that inventory. Okay, so the increase, you're increasing by part of what you have, and then you're selling part of what you have as well. So for the first part, let's talk about the 30% increase. Okay, so we're taking our inventory of 1,500, finding 30% of that, and then we're going to add that to what we already have. When we increase our inventory, we still have the 1,500, we're just adding more on top of that. Okay, so with this, we would be looking for the part. We have 30% and 1,500. Okay, so in this case, we would take 0.3 times 1,500 to get 450. So we don't have 450 toys. We're adding 450 toys to the 1,500 that we already have. So now 1,500. So we would be working with 1,950. So this is our current amount after the increase. So it's before the big shopping day. Part number 2, we sell 80% of the inventory. Okay, so let's find out how many toys we sold to determine how many are remaining. So we have 0.8 and we have 1,950. And so the two numbers are on the same level, so we multiply. And this would give us 1,560. Now, if you're not sure what to do with this number, remember what we just did. We sold 80% of our inventory. So does that mean we sold 1,560, or that's how many are remaining? That's how many we sold. We sold a whole bunch of toys, so we should be nowhere near the amount that we had after that sale. So in order to get the final answer, we would take 1,950 minus 1,560 to get 390 toys remaining. So this is our final answer. Another way you could do this problem, which we'll get into more in the next section, is if you sell 80% of your inventory, you have 20% remaining. So if you would have used 20% in part 2, you would have gotten 390 right away. I'll just mention that because I know some students think that way, which is completely fine. So either way you think about it, as long as it's correct, will work. Thank you for watching. If you have any additional questions, please feel free to reach out to me.